real exam questions. This is question 8, and it deals with slab design. Question goes as follows. Consider an isostatic slab load bearing in one direction with a concrete quality of C30-37. The maximum uniformly distributed load in ULS persistent with optimal use of the material is 40 kilonewton per square meter. What slenderness, L over D, would you apply in your design, knowing that you do not yet know the length of the span? We have that the characteristic value of the concrete compression stress is 30 megapascal. The load is 40 kilonewton per square meter, and the design value of the compressive strength of the concrete is 0.85 FCK divided by the material factor gamma C. 0.85 comes from the National Application Document Belgium. The reduced bending moment is defined as the bending moment divided by the BD squared FCD. From this equation, we can express it in D, in function of D, and then you have this expression. Now we will convert this expression by using the units D in millimeters, MSD in kilonewton per meter, and FCK in megapascal, or newton per square millimeter. So if you do that, you can simplify the equation to this form, which is practical in use. Now we will express G not in millimeter, but in meter. Then we divide by 1000. So strength is concerned, we know that the reduced bending moment is equal to 0.187 when the strain in the concrete is 3.5 per mil and the strain in the reinforcement steel is 10 per mil. In this case, we call an optimum depth. So we've seen that if you use the definition of mu d, then we have this expression, but now you can fill in mu d at optimum height. This means mu d is 0.187. Then you got this expression from D. Now the MSD, we also know that the bending moment and the maximum bending moment is QQ L squared over 8. We plug it in this formula, and we obtain an expression of D, or you can simplify it to get L of D out of this equation, or express the equation in function of L of D, and you got this expression. Note that this expression, in fact, is independent, or the number is independent of the length of the span, because this is defined there. Slenderness is then L over D. L over D equals to this. And now we know FCK was 30 megapascal and Q was 40 kilonewton per square meter. We fill it in this formula, and we find a slenderness of 25. So that means that for the design, even if you don't know the span, you know already that if you are going to design the slab with an optimum height, an optimum use of materials, you need a slenderness of 25.